following factors can bring about competition in a population? A. Emigration. Emigration has to do with organisms migrating out, moving out of that environment. So if they are moving out, there's no room for competition again. More resources will be made available for the ones left behind. Droughts, mortality, and dispersion. Mortality has to do with death. If the organisms are dying, they cannot compete with themselves again. When they are dispersed, when they are moved to different places, when they are scattered, that does not create room for competition. But when there is drought, the available water, the organism will compete for the little available water. So the correct option there is option B. So it is the factor that can bring about competition in the population. When there is drought, they will compete for the available water. Number 32. Stunted growth and poor development are a result of a deficiency of phosphorus, calcium, sulfur, and iron. So all this is to test our idea of the importance of all these minerals. So it is phosphorus that is responsible for growth and then root development. When it is lacking, the plant will be stunted and then the root development will be poor. So question 34, it says use the diagram below to answer questions 33 and 34. The cell organelle solely responsible for respiration is the A. nucleus, B. nucleolus, C. endoplasmic reticulum, D. mitochondria. Now, we have to get the correct understanding of what respiration is. Respiration goes beyond gaseous exchange. Gaseous exchange, where we take in oxygen and give out carbon dioxide, is called external respiration. We have internal respiration, where food is oxidized to release energy for the organism to make use of. And so, in the cell of plants and animals, there is a structure where this oxidation or breakdown of food to release energy takes place. It is not in the nucleus. The nucleus is an organ that has to do with cell division and then hereditary factors. The nucleolus is found in the nucleus. The endoplasmic reticulum is for transport. Then the place where respiration takes place and food is oxidized to release energy is in the mitochondria. When it is plural, it is mitochondria. So the correct option is the D, option D, mitochondria. Then 34. The organelle responsible for heredity is A4, B1, C2, D3. Now, if you look at the diagram very well, number 1 is pointing at the cell membrane. It is not responsible for heredity. Number 2 is the nucleus. Number 3 is pointing at the chromosomes. And then 4 are the nucleolus. So it is the chromosomes that are responsible for the transfer of characters from parents to their offspring. So the correct option there will be option 3, which is D. You cannot say the whole nucleus, because other parts of the nucleus, especially the nucleolus, has to do with cell division. So it is the chromosomes. Question 35 and 36. Look at the diagram very well. There are two hyphae here. This one is negative and positive. Come together, they have formed gametophagia, and then there is a fertilization here, a zygote is being formed here, and a thick substance surrounding it. So, question 35 says, the process illustrated is A, Gametogenesis. B. Sexual reproduction in rhizomes. C. Sexual reproduction in Spirogyra. D. Sporulation. Gametogenesis has to do with formation of gametes. And when the gametes are formed, it does not involve two parents coming together. Here, there is a positive hypha and a negative hypha, which symbolizes two parents. So gametogenesis cannot be the correct option. Now, if you look at this structure very well, it is found in rhizopus, and it is conjugation in rhizopus. And conjugation in rhizopus is a form of sexual reproduction. So B, sexual reproduction in rhizopus, is the correct option. That is what is illustrated in this diagram. Then the structure labeled 1 is the A, zygospore, B, conidiospore, C, sporangium, D, hyphae. Just like I have explained, two opposite hyphae. These ones are the hyphae, positive and negative. Now they have developed gametargia, and the gametargia has fused, and then to form the zygote. Then a thick substance, a thick coat has formed around the zygote to withstand adverse conditions. When that happens, the zygote is referred to as the zygospore. And so here, the structure here that is labeled 1 is the zygospore. Conidia is asexual structures in fungi. Sporangium cannot be, it is a sexual reproductive organ. But this one is sexual. So the correct option is zygospore. And you use the diagram below to answer questions 37 and 38. This is the structure of a paramecium. And the various organelles are labeled 1, 2, 3, and 4. Now, question 37. The organelle responsible for sexual reproduction is A4, B1, C2, D3. Now, in paramecium, there are two nuclei, the meganucleus and then the micronucleus. And when conjugation is to take place in two paramecium, the meganucleus will disintegrate. So it is the micronucleus that undergoes meiotic division, forming 4 nuclei. So the structure that takes part in sexual reproduction is the micronucleus, which is the structure labeled 3. So D is the correct option. Then question 38. A, respiration, B, ingression, C, locomotion, D, osmoregulation. Okay, if you look at the part that is labeled 4, is the anterior posterior, vacuum. So that one is for osmoregulation. It uses cilia for movement. Then for injection is the oral route. For respiration is by diffusion. So it is a contractile vacuum labeled 4 that brings about osmoregulation, maintaining water and salt balance in the body. So that organ brings about osmoregulation. No, it's the one up. Okay, it's the one up. 4. Paramecium has 2 contractile vacuums, the anterior and then the posterior contractile vacuums. And it is these vacuums that regulates the balance between the salt and water, and then excretion. So it is the organelle that brings about osmoregulation. So they say the part labeled 4 is responsible for osmoregulation and not respiration. Respiration is by diffusion. Ingestion is through the oral route here. Then locomotion is by the help of the cilia. But this organelle is used for osmoregulation. So D is the correct option. Okay. Use the diagram below to answer questions 39 and then 40. This is the structure of a mammalian heart. transection of a mammalian heart. It's labeled 1, 2, some parts are labeled 1, 2, 3, and 4. So the part labeled 1 is the pulmonary artery, bicuspid valve, aorta, and then vena cava. Now, the pulmonary artery, consider the options very well. Pulmonary artery is the only artery in mammals that carry deoxygenated blood. And it carries the oxygenated blood from the right ventricle to the lungs for oxygenation. Then bicuspid and tricuspid valves are between the right ventricle, right auricle and right ventricle, and then left ventricle and right ventricle. The aorta carries oxygenated blood from the left ventricle to all the parts of the body. Then the vena cava brings the oxygenated blood from all the parts of the body to the heart. So, the part labeled 1 here, as you can see, is from the left ventricle here. So, and it is carrying blood out, telling us that as it is carrying blood from the left ventricle, if you see the diagram like this, your right part is the left part of that diagram. So this is the left part of the heart, and this is the right part of the heart. So the aorta is the one that carries blood from the left ventricle and then circulates to all the other parts of the body. So it is the one that is labeled 1 here. So the structure that is labeled 1 there is the aorta. C is the correct option. Then oxygenated blood is pumped to the entire body from the part labeled A4, D1, C2, D3. Just like we said, when the oxygenated blood reaches the right auricle, it goes to the right ventricle, then through the pulmonary artery to the lungs. Then they return from the lungs, from the pulmonary vein to the left atrium, then to the left ventricle. From the left ventricle, the oxygenated blood will be pumped through the aorta to all the parts of the body. So the part that pumps oxygenated blood is the part labeled 4. Just come on. Okay? It is the part labeled 4. It is pumped from here, then through the aorta to all the parts of the body. So the correct option is option A for question number 40. Okay. So use the diagram below to answer questions 41 and 42. The experiment demonstrates, the experiment demonstrates hydrotropism, phototropism, pneumotropism, hydrotropism. Now, if you look at this diagram very well, the clinostat is used to demonstrate geotropism in plants. But from the options given here, there is no geotropism. Phototropism is response to light. Light is not here to show us how the plant is bending towards light. Hydrotropism is the response of the plant root towards water. And water is not shown here to show us the response of the root to water. So, there is no correct option for this question number 41. This is an experiment to demonstrate geotropism, and geotropism is not here. So there is no correct option for question number 41. Now, the part marked 1 will contain a high concentration of A, ethylene, abscisic acid, oxine, ascorbic acid. Now, if you look at the part labeled 1, before the radical comes, there will be higher concentration of a plant hormone called auxin, is a growth hormone, that will make this point grow quicker over the place that is far away here, so that it will bend over this one. So at the point label 1 here, there will be high concentration of auxin. So C is the correct option for question number 42. Then you use the diagram below to answer questions 43 and 44. There are two toads or frogs, one on top of the other, and in water. Eggs are being laid here, and some parts are labeled. Now, 43 says the breathing posture illustrated in the diagram is known as reproductive swimming and plexus, mating, then courtship. Okay? What they are doing is not reproductive swimming. And toad in courtship, the male toad will croak and then will attract the female toad to come by. So that croaking is the courtship in toad. But the posture that they have taken now, where the female toad has started laying eggs, is mating posture. So the correct option here is option C. The two frogs or toads here are mating. And question 44. The diagram shows that the organisms are A. Viviparous, B. Hermaphrodite, C. Ovoviviparous, D. Oviviparous. Oviparous. Now, if you look at this diagram, viviparous organisms are organisms that give birth to the young ones alive. But here, the diagram is showing us that eggs are being laid. So it cannot be viviparous. A hermaphrodite organism is an organism that contains both male and female gametes. But here the diagram is showing us that there are two organisms. One female laying egg and the male at the back of the female. So they are not a hermaphrodite. Ovoviviparity has to do with organisms that lays egg, but the eggs develop in the body of the organism before it hatches there, and then the young ones come out. So the organisms here are oviparous. So the correct option is option D. Organisms that lay egg are oviparous organisms.